Welcome to The Sleepy Astronomer, where the wonders of the cosmos gently unfold to help you relax, unwind, and drift into a peaceful state of mind. Tonight, we're turning our sleepy gaze toward the largest planet in our solar system, Jupiter. This massive gas giant may be doing more than just swirling with storms and moons. It might actually be protecting Earth. But how? And why does Jupiter seem to act like our cosmic guardian? Before we float into the stars, let us know in the comments where in the world you're watching from. Whether you're lying under the skies of Australia, listening in a New York apartment, or dozing off in a cozy village in Norway, we're so glad you're here. Now, settle in. Let's begin our journey. Far beyond the orbit of Mars, past the rocky trails of the asteroid belt, floats a planet so massive, so dominant, that it outweighs all the other planets in the solar system combined. This is Jupiter, a swirling, stormy giant, cloaked in bands of color and crowned with the Great Red Spot, a storm so vast it could swallow Earth whole. Jupiter is the fifth planet from the Sun and the largest by far. While Earth is a solid terrestrial world, Jupiter is what astronomers call a gas giant, a massive sphere composed mostly of hydrogen and helium, the same elements that fuel the stars. In many ways, Jupiter is more like a failed star than a true planet. Had it been just a little more massive, it could have ignited fusion in its core and shone dimly as a second sun in our sky. Its diameter is over 11 times that of Earth, and if it were hollow, over 1,300 Earths could fit inside it. Its gravitational pull is more than 25 times that of Earth's, making it a gravitational heavyweight in our planetary neighborhood. This immense pull doesn't just make objects fall faster near its surface, it warps the very fabric of the solar system around it, subtly tugging at other planets and small bodies like a gentle but persistent celestial shepherd. Yet despite its sheer size and strength, Jupiter doesn't have a solid surface. As you descend into its atmosphere, you wouldn't find ground to stand on. The gases simply grow denser and denser, eventually turning into a supercritical fluid, a strange state of matter that's not quite a gas and not quite a liquid. At the heart of this vast world lies something we can only guess at, a core perhaps made of rock or exotic ices, surrounded by crushing pressures and heat that are difficult to imagine. Its clouds swirl in dazzling patterns with hues of white, orange, brown, and even hints of red and pink. These bands are created by powerful jet streams that whip around the planet at hundreds of miles per hour. And within them, storms churn endlessly. The most famous of these is the Great Red Spot, a storm that has raged for at least 400 years, possibly much longer, and is still going strong. It's a haunting eye in the Jovian sky, silently watching the cosmos with turbulent patience. Jupiter has more than 90 moons, a miniature solar system of its own. Some of these moons are worlds in their own right. Ganymede, the largest, is even bigger than Mercury. Europa, encased in a shell of ice, may hide a deep subsurface ocean, potentially warmed by tidal forces, and rich with the ingredients for life. Io, the most volcanically active body in the solar system, constantly erupts with sulfur and fire. Callisto, dark and cratered, sits silently at the edge like a distant frozen sentinel. Orbiting the Sun once every 12 Earth years, Jupiter is a slow and steady traveler, but it spins incredibly fast on its own axis, completing a full rotation in just under 10 hours. This rapid spin gives the planet a noticeable bulge around its middle, making it appear slightly flattened at the poles. It also powers its enormous magnetic field, which is 14 times stronger than Earth's and extends millions of kilometers into space, creating a radiation environment so intense that it could damage unprotected spacecraft electronics in hours. Jupiter's magnetic field traps charged particles, forming powerful radiation belts that swirl around the planet. These belts are so dangerous that any spacecraft approaching the gas giant must be carefully shielded and maneuvered to avoid prolonged exposure. And yet, within this environment, Jupiter also creates auroras, dancing lights at its poles, far more powerful than anything we see on Earth, glowing constantly in ultraviolet and infrared like a distant lantern in the dark. Despite all its strength and fury, Jupiter isn't a threat to us. In fact, it may be our greatest cosmic ally. Its presence, so massive and gravitationally dominant, affects not just the objects near it, but the overall stability of our solar system. For billions of years, Jupiter has silently shaped the paths of asteroids, guided comets, and possibly shielded the inner planets, including Earth, from countless potential catastrophes. To truly understand why Jupiter might be protecting us, we first have to respect what it is. Not just the largest planet, but a force of cosmic balance. A titan of swirling storms and ancient power, watching over the solar system from afar. And as we float softly through the night, gazing into the dark skies above, it's comforting to know that somewhere out there, this silent guardian continues its timeless orbit, massive, mysterious, and always watching. Imagine, if you will, that the solar system is a grand celestial dance, a waltz of planets, moons, comets, and asteroids, all moving in intricate orbits around the brilliant flame of the sun. Each object follows a path carved by one thing: gravity. And while the sun's gravity is the dominant force holding everything together, there is another powerful partner in this dance: Jupiter. Jupiter's gravity is immense. In fact, it's second only to the sun's in terms of strength within our solar system. This gravitational force is not only responsible for shaping the orbits of its many moons, but also exerts influence across vast distances of space. Even millions of kilometers away, Jupiter's presence can tug, bend, and redirect the trajectories of wandering celestial objects. To understand the gravity of Jupiter, both literally and figuratively, it helps to remember just how much mass it holds. Jupiter contains over 70% of all the planetary mass in the solar system. Its gravitational field stretches so far that it doesn't just dominate its local space. It pulls on comets from the far reaches of the solar system, subtly steering their paths, even from hundreds of millions of miles away. This gravitational influence works in curious ways. Sometimes Jupiter acts as a deflector, bending the course of incoming objects away from Earth. Other times, it acts as a catcher, drawing these objects into its own orbit, or even into itself. This is especially true for comets and asteroids. As they journey toward the inner solar system, many of them are caught in the powerful net of Jupiter's gravity before they can ever reach Earth. But it doesn't end there. Jupiter's gravitational pull also plays a key role in shaping the behavior of entire regions of the solar system. Take the asteroid belt, for example, a vast field of rocky debris that lies between Mars and Jupiter. This region is not chaotic or random. It's structured and stabilized in large part because of Jupiter. Its gravity prevents the loose material from ever coalescing into another planet, constantly stirring it and maintaining the delicate balance of motion among these countless rocks. And then there are the gaps, known as Kirkwood gaps, within the asteroid belt. These are regions where very few asteroids are found, and they exist because of orbital resonances with Jupiter. An orbital resonance occurs when an asteroid's orbit aligns in a predictable rhythm with Jupiter's. For example, if an asteroid goes around the Sun exactly 3 times for every one orbit of Jupiter, their gravitational encounters repeat. Over time, these resonances can destabilize the asteroid's orbit, flinging it elsewhere, or ejecting it from the belt entirely. It's a quiet but powerful form of cosmic choreography. Beyond the asteroid belt, in the cold outskirts of the solar system, lies the Kuiper belt, and farther still, the distant Oort cloud, home to trillions of icy bodies and potential comets. Even out here, Jupiter's gravity can reach. As these objects slowly drift inward, perhaps nudged by other stars or galactic tides, Jupiter often determines their fate. Will they pass harmlessly by? Will they collide with a planet? Or will they be cast back out into the void? Jupiter's role isn't just in pushing and pulling objects, it's also in protecting the orbits of the inner planets. Earth, Venus, Mars, and Mercury all follow relatively stable paths around the Sun. That stability, so crucial for life on Earth, has been maintained over billions of years, in part because of Jupiter's gravitational buffering. If Jupiter weren't there, or if it had a different orbit or mass, the inner planets could experience chaotic changes in their orbits, possibly making Earth's climate far less stable and hospitable. And this gravitational protection is not just theoretical. Scientists who run computer simulations of the solar system, adding or removing planets to see what happens, have found that without Jupiter, the rate of dangerous asteroid and comet impacts on Earth would dramatically increase. The simulations suggest that Jupiter acts like a giant gravitational shield, intercepting many of the threats before they ever get close. But gravity is a double-edged sword. The same force that protects us could, under slightly different conditions, become a danger. If a rogue comet gets caught in just the right orbit, perhaps by passing near Jupiter first, its trajectory could be altered in such a way that it gets directed toward Earth. So while Jupiter's gravity is usually our ally, it is not infallible. It must be respected as a powerful force, one that can either guard us or, in rare circumstances, place us in the path of danger. Still, for the vast majority of cosmic events, Jupiter's gravity is a source of balance, order, and safety. Like a great cosmic lighthouse, it guides the drifting debris of the solar system, illuminating the safe paths and steering dangers away from our small blue world. Its presence is silent and unseen, but profoundly important, an unseen hand shaping the history of Earth from millions of miles away. As you lie back and drift into the gentle pull of sleep, think of Jupiter not just as a distant planet, but as a guardian of worlds, a colossal sphere of gas and gravity, humming softly in the darkness, guiding the rhythm of the solar system with ancient invisible hands. In the vast darkness of space, our tiny blue planet spins delicately around the sun, shielded not by walls or armor, but perhaps by something far more mysterious, a planet so massive and distant that it may be acting unknowingly as a protector. This idea, both comforting and awe-inspiring, is known as the asteroid shield theory, and at its heart lies the gas giant Jupiter. The asteroid shield theory proposes that Jupiter's sheer size and gravitational might allow it to act as a kind of cosmic vacuum cleaner or a gravitational shield that protects Earth from the countless asteroids and comets hurtling through our solar system. While Earth orbits peacefully in the so-called habitable zone, Jupiter patrols the outer edge of the inner solar system, absorbing, deflecting, or rerouting celestial bodies that might otherwise threaten our fragile world. To truly understand how this works, imagine a busy cosmic highway filled with rocky and icy debris. Every object in space moves according to the laws of gravity, and even a slight nudge from a passing planet can alter its trajectory in surprising ways. Jupiter's gravity is so strong that it has the power to catch many of these space wanderers, just like a net catches a wayward ball, redirecting them safely away from Earth. Most of these objects come from two major regions: the asteroid belt, which lies between Mars and Jupiter, and the distant Oort cloud and Kuiper belt, which harbour trillions of icy bodies, some as large as small moons. Occasionally, gravitational disturbances or collisions send these bodies careening toward the inner solar system, where they could pose serious threats. Jupiter, however, often steps in before they get too close. One of the clearest pieces of evidence supporting this theory is found in impact craters, not just on Earth, but across the solar system. While Earth bears the scars of ancient impacts, such as the one believed to have ended the reign of the dinosaurs, the number of massive impacts over billions of years is surprisingly low compared to what we might expect in such a debris-filled system. Jupiter's gravity is thought to play a major role in keeping those numbers low. The planet's influence is especially noticeable with long-period comets, those that originate in the farthest reaches of the solar system and only occasionally swing inward toward the Sun. These comets are some of the most dangerous because they move incredibly fast and are often too difficult to detect in time. However, many of them are intercepted or deflected by Jupiter before they ever reach Earth's vicinity. In some cases, Jupiter doesn't just redirect these objects, it swallows them whole. When a comet or asteroid comes too close, it can be captured by Jupiter's gravity and pulled into the planet's thick atmosphere, where it disintegrates. This kind of cosmic sacrifice happens more often than most people realize, and it's one of the ways Jupiter quietly keeps Earth out of harm's way. Astronomers have observed this shielding effect directly. In 1994, the world watched in awe as comet shoemaker Levy 9, a fragmented comet that had been torn apart by Jupiter's gravity, crashed into the gas giant over the course of several days. Massive explosions erupted in Jupiter's atmosphere, leaving dark scars bigger than Earth itself. It was a vivid reminder that Jupiter takes the hits for us, acting as a planetary bodyguard, absorbing blows that might have otherwise been aimed at our home. But Jupiter's protective role doesn't end with direct impacts. It also influences the orbits of objects across the solar system in more subtle ways. Through a mechanism called gravitational resonance, Jupiter can keep certain asteroid paths stable or destabilize others, causing them to move in safer directions. It even plays a role in maintaining the structure of the Trojan asteroids, which cluster around its orbit, locked into gravitational harmony. These groups of asteroids could otherwise drift unpredictably, but instead they remain safely corralled, far from Earth. Scientists continue to run detailed simulations of the solar system with and without Jupiter, and the results are striking. In most of these models, Earth becomes significantly more vulnerable to catastrophic impacts when Jupiter is removed or relocated. The number of high-speed comets and large asteroids reaching Earth increases dramatically. It's as though, without Jupiter, the solar system becomes more chaotic, less ordered, and far more dangerous. Yet the truth, as always, is more nuanced. Jupiter doesn't block every threat. In rare cases, its gravity can actually sling objects inward, like a gravitational slingshot, making certain orbits more elliptical and unpredictable. This means that while Jupiter protects Earth most of the time, it also has the potential to redirect danger our way. However, the vast majority of data and simulations suggest that Jupiter's presence greatly reduces the overall risk of catastrophic impacts. Some scientists believe that Jupiter's protective influence may have even been critical to the evolution of life on Earth. In the early days of the solar system, when the planet was bombarded by constant impacts, having a giant neighbor like Jupiter may have helped calm the chaos sooner than it otherwise would have. Fewer major impacts meant a more stable surface, one where life had the chance to take root, grow, and evolve over billions of years. As we look up into the night sky, it's easy to forget how fragile our existence truly is. Our planet orbits in a relatively quiet part of the solar system, shielded from many cosmic dangers, not by technology or walls, but by the quiet, relentless pull of Jupiter's gravity. Though we may never hear it, Jupiter's presence is like a deep hum in the background of space, a silent protector holding chaos at bay. So the next time you gaze into the dark sky and see a bright point of light, perhaps Jupiter itself glowing steadily among the stars, remember that this distant world might be the very reason Earth has remained a safe haven for life. A shield forged not of steel, but of gravity and gas, older than humanity and more enduring than any monument we could build. Jupiter, the quiet guardian, still watches. In the quiet summer of 1994, something extraordinary happened. Something so rare, so visually powerful, and so deeply revealing about our solar system that it changed the way we look at one of our planetary neighbors forever. It was not a mysterious signal from distant space or a spacecraft landing on a distant world. It was the slow-motion destruction of a comet, witnessed from Earth as it collided, piece by piece, with the massive body of Jupiter. This event, now known simply as the Shoemaker-Levy 9 impact, became one of the most striking demonstrations of Jupiter's role as our solar system's cosmic shield. The story of Shoemaker-Levy 9 begins more than a year before its dramatic end. In March of 1993, astronomers Carolyn and Eugene Shoemaker, along with David Levy, discovered a strange, elongated object near Jupiter while observing with a telescope at Palomar Observatory in California. At first, they believed it to be a typical comet, but its shape and appearance were unusual. It wasn't a single body, but a string of fragments, almost like a trail of cosmic breadcrumbs stretched across the sky. What had happened was astonishing. Sometime earlier, probably in 1992, this comet had ventured too close to Jupiter. The planet's enormous gravity had captured it, pulling it into orbit and tearing it apart in the process. The comet, likely made of ice and rock, had passed within Jupiter's Roche limit, a distance where the planet's tidal forces become stronger than the object's own gravitational cohesion. As a result, the comet was shredded into more than 20 large fragments, each ranging from 0.5 kilometer to 2 kilometers in size. These fragments, locked in a slow, fateful spiral, were now on a collision course with Jupiter itself. Astronomers were stunned. Never before had humanity witnessed a comet captured and broken by a planet's gravity, let alone seen the aftermath play out in real time. Over the next few months, telescopes around the world, and even in space, like the Hubble Space Telescope, were trained on Jupiter, watching with anticipation and a touch of nervous excitement. Then, in July 1994, the impacts began. One by one, over the course of several days, the fragments of Shoemaker-Levy 9 slammed into Jupiter's upper atmosphere at speeds of over 60 kilometers per second, more than 40 times faster than a speeding bullet. Each impact released an enormous amount of energy, equivalent to millions of atomic bombs detonating all at once. The resulting explosions didn't just leave tiny scars. They created towering plumes of material that rose more than 3,000 kilometers above the planet's cloud tops, visible even from Earth with moderate telescopes. The aftermath was shocking. Each impact left behind a dark, smudged scar on Jupiter's face, some of them larger than the entire Earth. These blemishes lingered for weeks, slowly fading into the planet's turbulent atmosphere. They were visual proof of the violent ballet occurring in the outer solar system, usually hidden from our view. What made the event so important wasn't just its visual drama, it was what it revealed about Jupiter. The collision showed us that this massive planet actively intercepts celestial threats. If Jupiter hadn't been there, if Shoemaker-Levy 9 had continued on a different trajectory, one or more of its fragments might have made their way toward the inner solar system, perhaps even toward Earth. While it's impossible to know the precise outcome, the event reminded scientists and the public alike that space is not empty or safe. It is dynamic, full of potential hazards, and deeply influenced by gravity. In the aftermath, scientists analyzed the impact zones to learn more about Jupiter's atmosphere. The collisions stirred up material from deep below the cloud layers, giving astronomers an unexpected glimpse into the planet's complex chemistry. They found molecules like ammonia and sulfur that had been dredged up from lower levels, clues about the planet's inner workings that would have otherwise remained hidden. But the deepest lesson came not from the chemical data, but from the realization of Jupiter's role in planetary defense. The Shoemaker-Levy 9 event demonstrated in the most dramatic way possible how Jupiter can attract and absorb potentially dangerous objects, protecting the inner planets, including Earth, from harm. It gave weight to the asteroid shield theory, which had previously been based mostly on simulations and orbital dynamics. Now there was direct evidence, observed, photographed, and recorded in real time. It was, in a way, a cosmic sacrifice. A comet destined for destruction was pulled away from the inner solar system and consumed by a giant too powerful to resist. And in doing so, Jupiter reminded us of its quiet, ongoing service as a planetary guardian. What's even more humbling is that events like this are not unique. Jupiter is thought to have absorbed or deflected countless comets and asteroids over the history of the solar system. Most of these impacts go unseen, swallowed in the vastness of space, or happening on the far side of the planet, away from our instruments. Shoemaker-Levy 9 was, in many ways, just one small example of a process that has been unfolding for billions of years. For astronomers, the event also served as a wake-up call. It underscored the importance of tracking near-Earth objects, understanding orbital mechanics, and appreciating the fragility of life in a dynamic cosmos. It sparked new discussions about planetary defense, not just from Earth-based measures like early warning systems and impact deflection technologies, but from the natural defenders already embedded within our solar system's architecture. And so, as the scars of Shoemaker-Levy 9 slowly vanished from Jupiter's surface, the memory of what we saw remained. A distant, gas-shrouded world had caught a volley of cosmic bullets and absorbed them without flinching. Jupiter had shown its power, not in violence, but in protection. It had stepped, silently and stoically, into the path of destruction. As we lie back tonight under Earth's protective sky, we might reflect on that moment, the dark marks left in Jupiter's clouds, the eerie beauty of the explosions, and the profound sense that we are not entirely alone in the universe. Even now, Jupiter watches over us, not with consciousness, but with mass and motion, a sentinel of storms, quietly keeping the chaos at bay. High above the swirling storms of Earth's atmosphere, where space stretches into an endless black sea, an invisible drama is always unfolding, a dance of comets, asteroids, and icy relics from the birth of the solar system. Some drift silently in stable orbits, never approaching the inner planets. Others, however, are restless travelers, nudged from their cosmic slumber by gravitational disturbances or ancient collisions. These nomads often make their way inward toward the heart of our solar system, toward us, and yet, remarkably, most of them never reach Earth. Many vanish before we ever know they existed. Some are deflected, some are destroyed, some are consumed, and many of these fates are sealed because of one colossal player standing at the edge of the inner solar system, Jupiter. Jupiter has earned the nickname of the solar system's cosmic vacuum cleaner for good reason. With a gravitational field that spans vast distances and a mass more than twice that of all the other planets combined, it acts like a massive net, sweeping through space and catching or redirecting the debris that crosses its path. But unlike a vacuum that simply pulls things in, Jupiter's role is far more dynamic. It alters the very orbits of comets and asteroids, capturing some into its gravitational grip, flinging others out into deep space, and occasionally swallowing them whole. Every object that ventures into the inner solar system is subject to the gravitational ballet orchestrated by the Sun and the planets. Jupiter, thanks to its enormous gravity, is one of the chief choreographers. Many long-period comets, those originating in the distant Oort cloud, enter the inner solar system with unpredictable trajectories. They are like cosmic bullets, fast-moving and difficult to track. But as they pass near Jupiter, something extraordinary happens. The comet's path bends, its speed changes. Sometimes it is captured into a new orbit around the Sun. Sometimes it is ejected from the solar system altogether. And sometimes it is drawn directly into Jupiter's own thick, swirling atmosphere, where it meets its fiery end. This process happens far more often than most of us imagine. Jupiter is pelted with objects on a regular basis. Some of these impacts are large and energetic, leaving behind temporary dark scars in its atmosphere, like the famous Shoemaker-Levy 9 collision. But many are small and fleeting, visible only through sensitive instruments that catch sudden flashes of light in the planet's cloud tops. These are the final moments of icy bodies that may have traveled for millions of years through space, only to be vaporized in a brief, silent explosion hundreds of millions of kilometers away from Earth. But the true wonder lies not just in Jupiter's ability to absorb these objects, but in its capacity to deflect danger. When a comet or asteroid approaches the inner solar system, its path may be slightly influenced by the distant tug of Jupiter's gravity. Even a small gravitational nudge applied far enough out can have massive effects over time. A comet that might have passed near Earth can instead be sent on a new trajectory, harmlessly skimming the Sun or returning to the outer edges of the solar system. In many cases, Jupiter doesn't even need to catch the object. Its mere presence is enough to change the odds. This protective quality is one reason some scientists believe that Earth has been uniquely sheltered throughout its history. During the chaotic early years of the solar system, countless objects rained down upon the planets, reshaping their surfaces and histories. Yet Earth, despite its many scars, seems to have emerged relatively unscathed when compared to what could have been. Some models suggest that without Jupiter, the frequency of catastrophic impacts on Earth would have been many times higher, possibly so high that the development of complex life would have been delayed or perhaps prevented altogether. One of the more fascinating aspects of Jupiter's vacuum-like behavior is its interaction with retrograde objects, those that orbit the Sun in the opposite direction of the planets. These objects, often traveling at extreme speeds, pose a unique threat. Their high velocity means that any collision would carry tremendous energy, far beyond what most impacts generate. Yet these objects, too, are influenced by Jupiter's massive reach. In fact, many retrograde comets that approach the inner solar system for the first time are slingshotted away or consumed by Jupiter before they ever have a chance to threaten Earth. The gas giant also plays a key role in shaping the paths of Jupiter family comets, a specific class of comets that orbit the Sun every few years and are heavily influenced by Jupiter's gravity. These comets often pass relatively close to Earth, but their orbits tend to be stabilized by Jupiter, kept in predictable paths that reduce the risk of sudden surprises. In a sense, Jupiter not only vacuums up danger, but helps organize it, keeping the solar system a more orderly and therefore safer place. Jupiter's immense magnetic field also plays a minor but fascinating role. While it doesn't directly shield Earth, it forms a vast magnetosphere that interacts with the solar wind and charged particles from the Sun. This interaction helps trap and absorb some of the smaller debris and high-energy particles moving through the outer solar system. Though it's not as immediately dramatic as deflecting a comet, this magnetic net adds one more layer to Jupiter's complex influence. It's important to remember that this protective effect isn't conscious or intentional. Jupiter doesn't know it's helping. It simply is what it is. A colossal, swirling, ancient sphere of gas and gravity, doing what physics dictates. And yet, through its passive influence, it becomes something far more poetic. A guardian, a gatekeeper, a silent sentinel standing between Earth and the cold chaos beyond. As you settle in tonight, perhaps letting your eyes flutter closed, you can imagine it. Jupiter, far away, humming with magnetic energy, its bands swirling like brushstrokes across a giant canvas. Somewhere, perhaps right now, a piece of ice and rock is spiraling inward from the far reaches of space, only to be caught in Jupiter's gravitational field and absorbed in a brief, silent flare. No sound, no warning, just a flicker in the darkness, and then peace. And thanks to this distant protector, Earth continues its journey, calm, fertile, and alive. Floating between Mars and Jupiter lies a vast region filled with fragments from the early solar system, a sprawling field of rocky debris known as the asteroid belt. It stretches across hundreds of millions of kilometers of space, a silent, sunlit graveyard of planetesimals that never quite formed into a planet. At first glance, it may seem chaotic, a place where rocks constantly collide, scatter, and drift. But in truth, the asteroid belt is remarkably structured, and much of that structure is owed to the gravitational influence of Jupiter. Jupiter's presence does not simply end at its own orbit. Its gravitational reach extends deep into the surrounding space, shaping the movements of countless objects. The asteroid belt is one of the most prominent regions where this influence is on full display. Though it lies between the orbits of Mars and Jupiter, the belt's behavior is anything but independent. It is sculpted, regulated, and even disrupted by the gas giant's gravitational power. To understand this influence, it helps to think of the asteroid belt not as a dense field of rocks, like something out of a sci-fi movie, but as a thinly populated region where objects are separated by vast distances. Still, even in this relatively sparse setting, Jupiter's effect is profound. One of the clearest demonstrations of this influence is the presence of the Kirkwood gaps, wide swaths within the belt where very few asteroids are found. These gaps are not random. They occur at specific distances from the Sun that correspond to orbital resonances with Jupiter. Orbital resonance is a fascinating phenomenon. It happens when the orbit of one object, such as an asteroid, becomes synchronized in a simple ratio with the orbit of another object, in this case, Jupiter. For example, if an asteroid completes exactly 3 orbits around the Sun for every 1 orbit that Jupiter completes, it's in a 3-to-1 resonance. At first glance, this might seem like a stable, even elegant relationship. But in reality, such resonances with Jupiter can become dangerously unstable. Because of the repeated gravitational tugs from Jupiter at the same point in the asteroid's orbit, these resonances cause small changes in the asteroid's trajectory to accumulate over time. Like gentle pushes on a child's swing, these consistent nudges can amplify the asteroid's eccentricity, pulling its orbit from a gentle circle into a more elongated ellipse. Eventually, the orbit becomes so stretched that the asteroid is thrown out of the belt entirely, either flung into deep space or sent inward toward the terrestrial planets. This sculpting process explains why the asteroid belt has gaps and why the remaining asteroids are grouped in certain zones. It's a quiet but relentless form of cosmic organization, with Jupiter's gravity acting like a conductor, guiding the dance of these ancient fragments. And yet, it's not just about stability. This same gravitational influence can occasionally send asteroids our way. When asteroids are nudged out of their stable orbits by a resonance, some of them end up on paths that cross Earth's orbit. These are known as near-Earth objects, or NEOS. While many of them are small and pose no danger, others are large enough to cause serious damage if they were ever to collide with our planet. And so, Jupiter plays a dual role. It both stabilizes much of the asteroid belt, preventing chaos, and occasionally destabilizes certain orbits, injecting new material into the inner solar system. But the story doesn't end with resonances. Jupiter also indirectly maintains order through its role as a gravitational barrier. During the early formation of the solar system, it's believed that Jupiter's mass and gravity was so dominant that they prevented a planet from ever forming in the asteroid belt. The debris that now populates this region likely represents building blocks that, under different conditions, could have merged into a full-fledged planet. However, the constant gravitational disruption from Jupiter kept these materials in a state of unrest, forever colliding, fragmenting, and dispersing, never able to coalesce. In this way, the asteroid belt is not just a leftover feature of planetary formation, it is a consequence of Jupiter's power. The planet didn't just shape the belt, it defined it. Every asteroid's orbit, every empty gap, every swath of debris is part of a celestial fingerprint left by Jupiter's presence. And beyond the belt itself, Jupiter's influence continues in the form of asteroid families and collisional clusters. When large asteroids are broken apart by impacts, the resulting fragments often follow similar orbits. These groupings, known as families, persist for millions or even billions of years, maintained by the gentle shaping of Jupiter's gravity. Without that influence, the belt might be more chaotic and dangerous, its debris more likely to wander into the inner solar system. It is also important to note that Jupiter isn't the only planet that shapes the asteroid belt. Mars has a subtle effect, and Saturn exerts its own distant gravitational pull, but none match the power of Jupiter. It is the architect of the belt, the gatekeeper, and in some ways, the silent sculptor of the entire inner solar system's architecture. For astronomers, the asteroid belt serves as a window into the solar system's past. Its contents are ancient, older than the Earth itself. These rocks preserve the chemistry and physical properties of the early solar nebula, offering clues about how planets formed and evolved. And at the center of this slow-moving symphony is Jupiter, orchestrating the balance between order and chaos, between movement and stillness. As you drift off tonight, let yourself imagine the vastness of that space, the long shadows cast by tumbling rocks, the soft silence between ancient fragments, the slow arcs of orbits guided by invisible threads of gravity. And out beyond it all, Jupiter looms, immense, radiant in the sunlight, watching, pulling, shaping. It is not just a planet. It is a presence, an unseen hand keeping the solar system in harmony. As we drift deeper into the solar system, past the asteroid belt and toward the orbit of Jupiter itself, we come upon a lesser-known phenomenon, one that is both peculiar and deeply fascinating. Locked in a kind of gravitational dance with Jupiter are vast swarms of asteroids that do not circle the Sun independently, nor do they orbit Jupiter like moons. Instead, they share its orbit. These celestial companions are known as the Trojan asteroids, and they are unlike anything else in the solar system. To the untrained eye, they might appear scattered or random, but their placement is precise, elegant even. These asteroids cluster in two massive groups that lie ahead of and behind Jupiter in its orbit around the Sun. One group leads Jupiter by about 60 degrees, and the other follows behind at the same distance. These two regions are known as the Lagrange points, specifically L4 and L5, where the gravitational pull of Jupiter and the Sun is perfectly balanced by the orbital motion of the asteroids. These are zones of stability, places where gravity and motion create a kind of safe haven for small objects. It's here, nestled in these gravitational pockets, that tens of thousands, possibly even hundreds of thousands, of Trojans reside. Some are small, just a few kilometers wide, while others are enormous. The largest, 624 hectare, is over 200 kilometers across. These are not merely rocks in space, they are ancient remnants, time capsules from the early solar system, frozen in place by the gravitational will of Jupiter. What makes the Trojan asteroids so intriguing is their potential role in the ongoing story of Earth's protection. While they are generally stable and do not pose an immediate threat to our planet, they exist in a delicate balance. If disturbed by collisions, orbital resonances, or outside gravitational nudges, some of them could be displaced from their comfortable nests and begin drifting through the solar system. And once that happens, the outcomes become unpredictable. Some displaced Trojans might be nudged into new, stable orbits elsewhere in the outer solar system. Others might be drawn inward, toward the asteroid belt or even the inner planets. In rare cases, a Trojan could become a near-Earth object with a trajectory that intersects our planet's orbit. While such events are rare, they are not impossible, and they add another layer of complexity to Jupiter's role as a protector. In this sense, Jupiter is not only influencing Earth's safety through direct gravitational shielding or absorption of dangerous bodies, it's also managing a collection of ancient companions that could, under the right conditions, become players in the grand ballet of celestial risk. For now, though, the Trojans remain still, orbiting calmly in their safe harbours. Their orbits are long and slow, their movements precise, and they seem content to follow Jupiter on its endless journey around the Sun. But there's more. Scientists believe that the Trojans could hold key information about the formation and evolution of the solar system. Some of these asteroids may be older than the planets themselves, untouched since the earliest days of the solar nebula. Their composition, ice, rock, carbon-rich compounds, can tell us about the conditions that existed when the planets were just beginning to form. And because of their stable positions, they may have been spared the violent collisions and heating events that reshaped other celestial bodies. In fact, these asteroids are so scientifically valuable that NASA has launched a mission to study them up close. The Lucy mission, named after the famous hominid fossil, is currently en route to visit several Trojan asteroids. The mission aims to provide insights into the building blocks of planets, and it represents our first detailed exploration of these unique objects. Lucy will not only fly past the leading swarm at L4, but eventually swing around to the trailing group at L5, a journey spanning nearly 12 years and covering billions of kilometers. From Earth, the Trojan asteroids are difficult to see. They are faint, far away, and often lost in the glare of sunlight near Jupiter's orbit. But with infrared telescopes and careful tracking, astronomers have mapped thousands of them. What they found is a rich, diverse population, some grey, some reddish, some covered in carbonaceous material that hints at complex chemistry. There are binary systems, where two asteroids orbit each other. There are oddly shaped ones, elongated or potato-like, casting strange shadows in the sunlight. These silent travelers, though stable for now, could one day evolve. The solar system is not a fixed system. Over millions and billions of years, orbits shift. Gravitational interactions accumulate. Chaos, though slow, is inevitable, and in that ever-changing cosmic environment, the Trojans are a wild card, a hidden variable in the equation of planetary protection. Jupiter, in its massive stillness, acts as a guardian and a herder, keeping these flocks of asteroids in line. Its gravity maintains the Lagrange points, balancing the push and pull between sun and planet, motion and stillness. Without Jupiter, the Trojans would likely disperse, drifting away into more dangerous or chaotic paths. But under its watch, they remain tethered to a gravitational choreography that has endured for billions of years. For now, the Trojans are more friends than foes, watchers of the giant planet, companions on its long orbit around the Sun. But their existence serves as a reminder of the delicate balance that defines our solar system. Even objects that appear stable may one day shift. Even protectors can harbor risks. And even the calmest orbit can, with the right disturbance, turn into a new path, one that leads inward, toward the heart of the solar system, where Earth lies spinning quietly, unaware. As you rest tonight, you can imagine them, those ancient stones, sailing through space in a slow, eternal dance with Jupiter. They don't make a sound, they don't flicker or flash, but they are there, following, waiting, dreaming perhaps of the early days when the sun was young and the planets were still finding their place. They are reminders that even the most distant and seemingly minor parts of the solar system play a role in the grand, silent protection of Earth. For all its power, beauty, and apparent role as Earth's guardian, Jupiter is not without its mysteries or its potential to surprise us. While much of the scientific community regards Jupiter as a largely protective presence in the solar system, there is a quieter, more unsettling side to its story. Because while Jupiter often serves as a deflector and absorber of cosmic threats, it also possesses the potential to do the exact opposite. Under the right conditions, the very same gravitational force that protects us could become the mechanism that places us in danger. To understand this paradox, we must look again at the immense gravitational pull that gives Jupiter its status as a planetary giant. Its gravity doesn't simply catch wayward comets and rogue asteroids like a net. It also has the power to redirect them. When a small body, say a comet from the distant Oort cloud or a wandering asteroid from the outer belt, passes near Jupiter, its trajectory is altered. This effect, known as gravitational scattering, can be subtle or extreme, depending on the angle, speed, and distance of the encounter. In many cases, the object is flung away from the inner solar system entirely, ejected into the dark expanse between the stars. But sometimes, the altered path bends inward, toward the sun and toward the inner planets. This is where Jupiter's dual nature becomes apparent. It is not a perfect shield, it is a gravitational wildcard, capable of sending objects hurtling toward Earth just as easily as steering them away. There's no malevolence in this, of course. Jupiter is not conscious. It doesn't aim or decide. It simply follows the immutable laws of physics. But those laws can lead to strange and even dangerous outcomes. Simulations run by planetary scientists have shown that, depending on the initial trajectory of a comet or asteroid, a close encounter with Jupiter can produce a wide range of orbital outcomes, some of which include placing that object on a direct collision course with Earth. One of the most haunting examples of this possibility came in 1770, when a comet known as Lexell's Comet passed incredibly close to Earth, closer than any other comet in recorded history. Just 6 years before that encounter, it had been thrown into this Earth-crossing orbit by a gravitational interaction with Jupiter. It came within 2.2 million kilometers of our planet, astronomically speaking, a near miss. And then, just as suddenly, a second encounter with Jupiter altered its orbit once more, casting it into a new path and out of Earth's reach. This eerie dance, where Jupiter flung a potentially dangerous comet toward us, only to snatch it away again, serves as a chilling reminder that the gas giant's influence is complex. It can be savior and threat, guardian and guide. Modern simulations further reinforce this ambiguity. In one set of studies, researchers removed Jupiter from virtual models of the solar system to observe the effects. What they found was surprising. While in many scenarios, Jupiter's absence increased the number of Earth impacts, in others, its removal reduced them. How could that be? It turns out that Jupiter's position and mass make it not just a shield, but also an occasional facilitator of orbital chaos. By disturbing the orbits of objects in the asteroid belt, or among the Jupiter family comets, it can inject new bodies into the inner solar system, some of which may cross Earth's path. In some models, smaller gas giants, or even Saturn alone, result in a quieter inner solar system. This doesn't disprove Jupiter's protective effect overall, but it introduces a nuance. Jupiter filters threats, but it also generates them in small, unpredictable numbers. And there's another layer to this story. As Jupiter slowly moves through its own orbit, It interacts gravitationally with other planets, especially Saturn. These interactions can slightly alter the shape and orientation of Jupiter's orbit over long timescales. Such changes can modify the locations of orbital resonances in the asteroid belt and elsewhere, potentially opening up new pathways for objects to migrate inward toward Earth. Over millions of years, these slow shifts could reshape the flow of cosmic debris, increasing or decreasing the hazard depending on the specific configuration of the planets. In even more extreme cases, theorists have imagined what might happen if Jupiter's orbit were significantly altered, either by a massive collision or by gravitational interaction with an interstellar visitor like a rogue planet. While such events are purely speculative and extraordinarily unlikely, they highlight how much Earth's safety depends on the current arrangement of planetary bodies. A shifted Jupiter could destabilize the solar system's fragile equilibrium, sending waves of asteroids and comets inward in unpredictable cascades. And then there is the notion of time. Humanity has existed for only a blink of cosmic history. The planet Earth is 4.5 billion years old. Civilization is perhaps 10,000 years old. Our records of celestial impacts cover only a tiny slice of that timeline. So when we say Jupiter is a protector, we must also acknowledge the limited scope of our experience. There may be epochs, long before or long after our time, when Jupiter's gravitational mechanics bring more chaos than calm. The cosmic pendulum may swing both ways, its direction governed by slow, invisible forces we are only just beginning to understand. So, could Jupiter ever turn against us? Not in the dramatic, mythic sense. It will not awaken with anger or hurl comets at Earth with intention. But yes, in a quieter, colder sense, through random gravitational encounters and orbital dynamics, it could, and possibly has, sent dangerous objects our way. And yet, even with this knowledge, the overarching picture remains one of balance. Jupiter gives far more than it takes. Its mass, its position, and its role in shaping the solar system have made Earth a more hospitable, more stable place. The occasional dangers it presents are part of the same mechanics that largely protect us. The chaos and the calm come from the same hand. As you rest tonight, imagine Jupiter out there, immense, turning silently in the dark, its storms swirling endlessly, its moons spinning in frozen ballet. It is not our enemy. It is not our savior. It is simply what it is. A force of nature, ancient and immense, shaping the fates of worlds with its silent, indifferent pull. And in that quiet certainty lies a strange kind of comfort. While Jupiter often takes the spotlight as the mighty guardian of the solar system, it is not the only giant watching over the cosmic frontier. Just beyond Jupiter, orbiting at nearly twice the distance from the Sun, lies Saturn, a planet of beauty, mystery, and subtle power. With its iconic rings and golden hue, Saturn may seem more like a decorative jewel than a defender. But behind its calm and graceful appearance lies a gravitational force that, while not as overwhelming as Jupiter's, plays a critical role in the structure and safety of the solar system. Saturn is the second largest planet in the solar system, and though it is less massive than Jupiter, its gravitational influence is still enormous. It contains more than 95 times the mass of Earth and exerts a gentle, far-reaching pull on everything around it. If Jupiter is the dominant conductor of the solar system's outer orchestra, then Saturn is the co-conductor. Slightly quieter, more subtle, but no less essential. One of Saturn's most important contributions is its gravitational partnership with Jupiter. These two giants do not exist in isolation. They engage in a delicate gravitational dance, influencing each other's orbits as well as the orbits of objects far beyond their immediate vicinity. Their combined effects help stabilize certain regions of the solar system, particularly the asteroid belt and the Kuiper belt. Without Saturn's balancing presence, Jupiter's gravitational disturbances might create even more chaos than they already do. This dynamic relationship is especially important when it comes to orbital resonances. Just as Jupiter creates resonant gaps in the asteroid belt, Saturn contributes by shaping other regions through its own gravitational rhythm. In some parts of the solar system, Jupiter and Saturn's resonances overlap, creating zones of instability where asteroids and comets are more likely to be ejected, scattered, or sent inward. These overlapping zones serve as cosmic pressure valves, preventing the long-term accumulation of dangerous objects in certain orbits. One of the most fascinating examples of Saturn's role in planetary protection comes from the Kuiper Belt, a vast ring of icy bodies that lies beyond Neptune. Many of the short-period comets that eventually pass near Earth originate here. Their journeys are often guided by the gravitational influence of both Jupiter and Saturn, who act like gatekeepers, determining whether a comet is flung out into deep space, pulled into a stable orbit, or drawn into the inner solar system. Saturn is particularly influential in shaping the orbits of comets that pass through the outer solar system migration routes. These migration routes are complex gravitational corridors, narrow bands through which icy bodies travel when they are nudged inward by gravitational interactions or collisions. Saturn's presence affects the shape and speed of these corridors, sometimes deflecting objects away from dangerous paths, and other times slowing them down enough for Jupiter to capture or eject them. In addition to guiding and redirecting cometary orbits, Saturn also has its own family of irregular moons and captured objects. Some of these moons are thought to be former asteroids or Kuiper Belt objects that wandered too close and were pulled into Saturn's gravitational field. These captured bodies help Saturn clean up the surrounding space, reducing the number of rogue objects that might otherwise continue drifting inward. In this way, Saturn acts like a gravitational buffer, sweeping up debris before it can pose a risk to the inner solar system. But Saturn's influence isn't purely defensive. Like Jupiter, it has the capacity to redirect objects in unexpected ways. There have been scenarios modeled in which Saturn's gravity alone, or in concert with Jupiter, could alter the trajectory of a passing comet and send it on a collision course with Earth. These situations are rare and usually depend on very specific orbital alignments, but they remind us that the gas giants are not infallible shields. Their power is great, but their influence is impartial. They move objects according to the laws of motion and gravity, not according to the needs or wishes of life on Earth. Saturn's role becomes even more fascinating when we consider the early solar system. During the chaotic period known as the Late Heavy Bombardment, billions of years ago, it is believed that the outer planets migrated into new orbits, possibly due to interactions with a disk of leftover planetesimals. This migration may have triggered a gravitational disturbance that sent a wave of comets and asteroids hurtling toward the inner solar system, but it also helped reshape and redistribute the debris, leading to a more stable configuration in the long term. Saturn, in tandem with Jupiter, may have helped shepherd this chaotic process toward a more orderly and life-permitting solar system. In this sense, Saturn's protection is both active and historical. Its influence is not only felt in the present moment, but has been shaping the solar system for billions of years. Its gentle but persistent gravity has helped maintain the delicate balance required for Earth to remain in a stable orbit, free from excessive bombardment and orbital disruption. Even Saturn's rings, beautiful and seemingly fragile, are the result of gravitational interactions. These rings, composed of ice and rock, are a visual testament to the planet's ability to capture and control matter. Some scientists believe that the rings may have formed from a destroyed moon or a captured comet, torn apart by Saturn's tidal forces. If so, they represent yet another way in which Saturn reshapes its surroundings, absorbing potential threats and repurposing them into serene, swirling structures. As we look to the future, Saturn continues to be an object of intense scientific interest. Missions like Cassini have already revealed the planet's deep atmospheric mysteries, its strange magnetic field, and the incredible activity of its moons, such as Enceladus, which ejects icy plumes into space from a hidden subsurface ocean. These discoveries show us that Saturn is not just a passive participant in the solar system, but a dynamic world with the power to shape its environment. As you close your eyes tonight and drift towards sleep, picture Saturn in your mind, not just as a distant ringed planet, but as a quiet guardian, spinning in the darkness far beyond our skies. Its golden bands rotate slowly, its moons trace delicate arcs, and its gravitational reach extends far beyond what the eye can see. It is not loud. It does not command attention like Jupiter. But its influence is steady, essential, and enduring. Saturn may not always receive the credit it deserves, but without it, the solar system would be a more chaotic, less hospitable place. In the great cosmic symphony that plays out across time and space, Saturn is the soft, low note beneath the melody, subtle, steady, and always present. A second guardian, standing beside Jupiter, keeping the long night just a little more peaceful. Far beyond the moon, beyond the Earth's protective magnetic field and the blue shimmer of its oceans, there lies a realm of swirling giants and ancient forces. Among them, Jupiter towers, not with hostility, but with quiet vigilance. It does not shine like the sun or sparkle like the stars, but it plays a role perhaps more profound than any of them for the survival of our fragile planet. Over billions of years, this immense world of storms and gas may have acted as Earth's guardian, a planetary shield forged not of intention or design, but of gravity, mass, and the quiet poetry of celestial motion. When we look at Jupiter through a telescope or in high-resolution photographs from spacecraft like Juno or Galileo, we see its familiar bands of orange, brown, and white. We notice the great red spot swirling eternally like a scar of time. We are captivated by its size, so vast that more than 1,300 Earths could fit inside it, and by its sheer dominance in the planetary hierarchy. But what we cannot see, what hides behind the beauty, is the subtle and profound influence Jupiter exerts across the solar system. It is not just a planet. It is a kind of planetary guardian angel, a stabilizer of orbits, a deflector of danger, and perhaps one of the unsung reasons why life on Earth has been allowed to flourish. From the earliest days of the solar system, Jupiter has been a shaping force. When the sun first ignited and the planets began to form, dust and gas swirled in a chaotic disk around our newborn star. As material coalesced into clumps, then planetesimals, then full planets, Jupiter emerged as a giant, its mass growing rapidly until it became so gravitationally powerful that it began to clear out vast regions of space around it. It swallowed some material, scattered other bits into deep space, and captured yet more in stable orbits around itself. In doing so, it began to sculpt the architecture of the solar system as we know it today. It prevented the formation of a planet between itself and Mars, leaving behind the fragmented asteroid belt. It redirected comets and icy bodies from the outer regions, often intercepting them before they could plunge toward the inner planets. Some it cast away into long, harmless orbits. Others it devoured, taking the blow that could have ended a world like Earth. This role is not a one-time act of cosmic heroism. It is ongoing, constant, and unseen, like a quiet watchman at the edge of a city wall. Jupiter does not need to act with force to protect. Often, its mere presence is enough. Its immense gravity gently nudges objects away from dangerous paths, exerts long-term stability on Earth's orbit, and reduces the likelihood of major impacts that could reset or even erase life. But perhaps more poetically, Jupiter is a symbol of balance in a universe where chaos often reigns. While stars are born and die in violent explosions, and comets tear through the sky on unpredictable trajectories, Jupiter persists in its silent vigil. It rotates faster than any other planet, spinning once every 10 hours, its clouds swirling at hundreds of miles per hour. Yet it never falters. It has endured the test of time. And in doing so, it has quietly allowed Earth to become what it is. A cradle of life, consciousness, and wonder. Even Jupiter's moons echo this theme of quiet guardianship. Europa, Ganymede, Callisto, and Io, the Galilean moons, are themselves like miniature worlds. Some may harbour subsurface oceans, locked beneath icy shells. These worlds, too, have been protected by Jupiter's gravity, their orbits maintained with precision through gravitational resonance. The very rhythm of their motion, the predictability of their paths, is a testament to the order Jupiter brings. And yet, Jupiter is not a perfect protector. As we've seen, it can occasionally direct danger toward us, but that too is part of the balance. For Earth to evolve, to become the planet we know, it had to endure some impacts. The very presence of water, the seeds of organic molecules. These may have been delivered by comets or asteroids, some of which may have first been tugged by Jupiter into paths that intersected with Earth. In this way, Jupiter is not just a shield. It is a gatekeeper of fate, allowing some challenges to reach us while guarding us from annihilation. It is a cosmic paradox. Without the occasional impact, there may have been no oceans. Without a long era of stability, there may have been no time for life to develop. And without Jupiter's gravitational intervention, there may have been no stability at all. Earth may have endured endless bombardments, chaotic orbital shifts, or even gravitational ejection from the solar system altogether. So in our moments of stillness, when we gaze up at the night sky, when we marvel at the silent dance of the planets and stars, it is worth remembering that our place in the universe is not solely the result of luck. It is also the result of balance, of mass, of gravity, of the silent pull of distant giants who ask for no recognition, no thanks, and yet have shaped the destiny of our world. Jupiter has no voice. It will never write poems or paint paintings or sing songs. But if it could, perhaps it would offer only one quiet truth, that in this vast and ancient universe, sometimes protection comes not from walls or weapons, but from steady presence, from enduring strength, and from the invisible threads that hold everything together. So as you close your eyes tonight, breathing softly, remember that far out in the dark, Jupiter is there, turning, swirling, glowing faintly in reflected sunlight. Not because it must, not because it chooses to, but simply because that is what it does. A guardian in the dark, a planetary angel, a silent force keeping the stars just a little more kind to us.